Welcome to PreMath. In this video, we have got this golden triangle EFG fully inscribed in a rectangle ABCD, as you can see in this diagram, such that this golden triangle is an isosceles triangle, since this side length EG equal to this side length FG. And moreover, this angle is 90 degrees. And furthermore, this side length of this rectangle AD is 28, whereas this line segment EC is 21, and this line segment EB is 7 units. And now our task is to calculate the area of this golden triangle. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. We can see that these 3 points E, F, and G not only give us this golden triangle EFG, but also it yields this trapezoid ADFG, this right triangle ECF, and this right triangle GBE. And here's our very first step. I have drawn this auxiliary line FP by dropping a perpendicular on this side AB, and as a result we got this right triangle GPF. And here's our next step. Let's assume that alpha and beta are our two complementary angles. In other words, the sum of these two angles alpha and beta must be equal to 90 degrees. Now let's assume that this angle in this triangle EBG is alpha. This angle is 90 degrees, so therefore this angle is going to be angle beta. And now we know that this angle is alpha, this angle is 90 degrees, so therefore this angle has got to be our angle beta. Finally, let's focus on this right triangle GPF. This angle is beta, this angle is 90 degrees, so therefore this angle has got to be our angle alpha. So therefore we conclude that these two right triangle GPF and this other right triangle GBE are congruent triangles according to angle side angle congruency theorem. Since these two side length EG and FG are congruent, and the angles are alpha, beta in this triangle, and likewise alpha and beta over here as well. And since these two triangles are congruent, so therefore this segment PG is going to be congruent to this tiny side length EB. And since this side length is 7, so therefore this PG length is going to be 7 units as well. And furthermore, let's make an observation. We can see that these lines AD and this line FP are parallel lines. If this side length is 28, then this FP length is going to be 28 units as well. And now let's focus on this right triangle GPF, whose side lengths are 7 and 28. And we are going to use the Pythagorean theorem to figure out this side length FG. And here's our Pythagorean theorem: a square plus b square equal to c square. Let me go ahead and call this longest leg as our side C. I'm going to call this side lowercase a and this side lowercase p. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is 7, so this will become 7 square plus b in our case is 28 whole square equal to c square. So 7 square is going to give us 49 plus 28 square is going to give us 784 equal to c square. So therefore c square turns out to be 833. Let's go ahead and undo this square by taking a square root on both sides, and we can see this square and square root undo each other. So therefore our c value turns out to be square root of 833. And now we can see that this C represents this side length FG. So therefore our this FG length turns out to be square root of 833. And now let's focus on this golden triangle EFG. It is an isosceles triangle since this side length FG equals to EG, and since this side length FG is square root of 833, so therefore this side length EG is going to be square root of 833 as well. And now let's focus on this golden triangle EFG. It is a right triangle, and its both of side lengths are square root of 833 and 833 square root as well. And here's our final step. Let's go ahead and calculate the area of this golden triangle EFG. Now let's recall the area of a triangle formula. Area equals to a half times base times height. And for this golden triangle, which is a 90-degree angle, so therefore this is going to be our base EG, and our height is going to be FG. So let's go ahead and fill in the blanks in this formula. So therefore our triangle area is going to be equal to a half times our base is square root of 833 times height is square root of 833 as well. So let's go ahead and simplify the right hand side. So this is going to give us 1 over 2 times when we multiply square root of 833 times square root of 833, that is going to give us simply 833. So therefore I can write 833 over here. So 833 divided by 2 is going to give us 416.5 square units for this triangle area EFG. So thus after all the manipulations and constructions, we got the area of this golden triangle EFG as 416.5 square units, and that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.